All right, let's work through our semester exam review, starting with these angular and linear velocity questions. Question number 1, a child is spinning a rock at the end of a 2-foot rope at the rate of 120 revolutions per minute. Find the linear speed in feet per minute when the rock is released. On all these angular linear velocity questions, what you want to do is identify the rate that you're given to start with. In this case, that rate is 120 revolutions per minute. And then you want to find what you want to end up with, the linear speed in feet per minute. So the units that we start with and what we want to end with, they kind of tell you how to solve the problem. So I'm going to start with our given information, 120 revolutions per minute, and I want to convert that to feet per minute. So I already have minutes in the denominator. I'm good there. I need to convert revolutions to feet. One thing that you have to remember on angular and linear velocity problems is that 1 revolution is equal to circumference of the circle. All of these problems are going to involve circles. 1 revolution equals circumference. You can find circumference by 2 pi, multiplying 2 pi times the radius, or pi times the diameter, depending on what information you're given. Now in this problem, we're spinning a rock on the end of a 2-foot rope. So that 2 feet is a radius of the circle that's formed when we spin this rope around. And so revolutions are on top. I'm going to put 1 revolution on bottom, and that's going to be equal to 2 pi times the radius, which is 2 feet. Revolutions cancel, which is what I want to happen, and I have feet per minute, which is what the question asked me to find. So we can put this in our calculator, 120 times 2 pi times 2, and for an answer here, you can either give me 480 pi feet per minute, or if you prefer a decimal, that comes out to be 1,507.964 feet per minute. Now on this next question, number 2, the diameter of a wheel of a bicycle is 26 inches. If you were traveling on this bicycle at a speed of 25 miles per hour, what is the angular velocity of the wheel in revolutions per minute? Again, 25 miles per hour is the rate that we're given. We want to convert that to revolutions per minute. So I'm going to work this down here. I'm going to start with 25 miles per hour. Now I noticed that in my final answer, instead of hours, I want minutes. So I'm going to take care of that first. Hour is on bottom, so I'm going to put 1 hour on top, and I know that's equal to 60 minutes. Hours cancel, and now I have minutes, which is what I need for my answer. So I'm good there. Now I need to convert the miles, and I want to change miles to revolutions. Now remember from the previous problem, 1 revolution is equal to circumference, and in this case I have a diameter of our circle which is 26 inches. So that means I'm going to be able to get circumference in inches. My given information, however, is in miles, so I need to convert that to inches. Miles on top, so I'm going to put 1 mile on bottom, equal to 5,280 feet. And then I'm going to convert, miles cancel. Just cancel them out. Now I'm going to convert feet. 1 foot is equal to 12 inches. Feet cancel. Now I have inches. Now I'm ready to convert to revolutions. Inches on top, I want inches on bottom equal to 1 revolution. And 1 revolution equals circumference. In this case, I'm given the diameter, so I'm going to do pi times the diameter, pi times 26 inches. Inches cancel out, and I have revolutions on top, minutes on bottom. That's what the question was asking me for. Now, we're ready to put this in the calculator. When you put it in the calculator, I would use that fraction template. On the top, put all your numbers from the top, 25 times 5,280 times 12, and then on the bottom we have 60 times pi times 26. All the numbers on the top multiply, all the numbers on the bottom multiply. And if you put that in your calculator, you're going to get 323.207, there's my decimal, revolutions per minute. All right, let's move on. Next section is on periodic functions. Now notice we have this periodic function here. It's a repeating pattern, and what's important about periodic functions is to determine what the period is. In this case, it looks like I have a pattern that begins at 0 and finishes at 6. What this question is asking me is, what is the function value at 24? When x is 24, what is the y value or the function value? Well, 24 is divisible by 6, and so that means that by the time I get to 24, I'm going to be back at this point right here on the function, which means my function value, my y value at that point, is 0. On the next one, our x coordinate is 41. We want to know what's the function value at 41. Well, 41 is not divisible by 6. A close number to 41 that's divisible by 6 is 42. And so I know when I get at x equals to 42, I'm going to be at this point on the graph. 41 is going to be 1 unit before that. And if I go down to the graph, my function value here is -2. Now at -25, so this means we're going to be moving in this direction on the graph. -25 is not divisible by 6, but -24 is divisible by 6. And so I know at -24 I would be right here at this point on the graph. -25 would be 1 unit later. And again, that's going to correspond to this low value down here at -2. All right, our next section is just checking to see if we know the parent functions for sine and cosine. On the first one here, y is equal to sine x. Now when you sketch this graph, it does not have to be a perfect graph. I would like to see at least one label on the y-axis. I would probably prefer 2. And labels on the y-axis from 1 to -1. That is the sine graph. It starts at 0, it goes up, back to 0, down to -1, and then finally finishing at 0. Our domain for sine is all reals. X can be anything. There's never any breaks or asymptotes in this graph. The range, however, is limited between -1 and 1. There's 2 ways that you can write this answer. -1, less than or equal to y, less than or equal to 1. That's one way to express the answer. Or if you prefer interval notation, we can say -1 to 1. Now notice there's brackets on my interval because we are including the -1 and 1 values. And also if you use interval notation, that -1 must come first. The lowest number has to come first. The period for this function is 2 pi. Cosine graph. Cosine starts up at 1 pi and 2 pi. I'm going to start up here at 1. It's at 0 at pi over 2, -1 at pi, back to 0 at 3 pi over 2, and back up to 1 at 2 pi. So my parent graph looks like this. Domain and range and period, they're all going to be the same as they are for sine. The domain is all reals. The range, again, is between -1 and 1. -1 less than or equal to y, less than or equal to 1, or interval notation. And the period, again, is 2 pi. Let's move on to the graphs. In this first graph, number 6, y equals sine of 2 times x minus pi over 4. There's 2 transformations here. We've got a number right here being multiplied by x, and then we also have a number being subtracted from x. If you remember from our transformations, this is the b and the c. This number affects the period. This number is a horizontal shift. For period, you need to remember our little formula, 2 pi divided by b. In this case, 2 pi divided by 2 is equal to 1 pi. So that means my period is 1 pi. I need to complete a full cycle of sine in 1 pi. Now this minus pi over 4, this is a horizontal shift. And remember, whenever we're shifting horizontally, we're going to go in the opposite direction of what we think. It says minus. We think that should be to the left. It's actually to the right. We need to shift right pi over 4. So let's draw a set of axes for our graph. Now I'm going to say if I give 4 squares to be equal to pi, because remember usually I like 4 squares to be equal to the period, and that means every square would be pi over 4. And since I'm shifting right pi over 4, this scale is going to work for me. So this is sine. We haven't changed the range, so it's going to be going from 1 to -1. I'm going to be starting here at pi over 4. My period is pi, which does not mean that I'm stopping at pi. It means that I'm stopping pi units later after where I'm starting, which is, we have said from the beginning that pi is going to be 1, 2, 3, 4 squares. But instead of starting at 0, I'm going to start here at pi over 4 and count 1, 2, 3, 4 squares. That means that my graph should be finished. I should complete the whole sine graph by the time I get to there. Amplitude is not changed. It's still 1 and -1. So there's my little framework, and we're going to fit we're going to fit the sine graph in here like this. Remember, sine starts in the middle, it goes up, back to the middle, down, back to the middle. And then if we want to do one more cycle, it would look like that. Question number 7. Here we have y equals -3 cosine x plus 2. So I have a number in front here, that's an a, and then I have plus 2 on the end, which is not grouped with the x. So that means it's not a horizontal shift, it's a vertical shift, which is going to be our d. This 3 means that my amplitude is changing to 3. And then this plus 2 at the end is going to be a vertical shift up 2. So remember, I like to think about the vertical shift first. On my y-axis, I think I'm just going to count by ones. Every square be 1. So my vertical shift is up 2. That means that my middle line, which normally the middle line is at 0, now my middle line is going to be at 2. The D tells you where the middle line is, the middle of your graph. All right, I need a scale on my x-axis. And now notice the numbers that were given here, the transformations that were given, both affect y coordinates. They do not affect x coordinates. So we can label the x-axis in and just however you normally label it. My period is not changing, and I do not have a horizontal shift. So I'm going to be starting the graph right here. I need to finish by 2 pi, which means my graph needs to finish here. Now I do have an amplitude change of 3. So from the middle line, I'm going to count up 1, 2, 3. That is the top of my graph. I'm also going to count down 3, 1, 2, 3. And that should be the low point of my graph. Let's see, the middle is right here. So there's my framework. Now I go back and look and see that the equation is asking me to graph cosine, and we also need to remember we have this negative number here, negative on the A. And so normally if I'm graphing cosine, I would start up at the top of the frame, but since it's negative, I'm going to start at the bottom of the frame. And then it's going to go to the middle, to the top, to the middle, and back to the bottom. And there's one cycle of cosine. And we can do one more. I think I have room, just barely. One more cycle. All right, let's move on to the next question. On number 8, y is equal to 1/2 cosine 2x. So this time I have a number in front, which is an amplitude change, and then I have a number in front of the x, which is going to affect the period. My new amplitude is 1/2. My period is equal to, remember the formula, 2 pi divided by b. My b is 2, so 2 pi divided by 2 is equal to pi. All right, so on my y-axis, I have an amplitude of 1/2, which is kind of a small amplitude. I'm going to go ahead and give it 2 squares. I'm going to mark off 2 squares there and say that's 1/2, and say this is negative 1/2. You could do 1 square and that would be fine. For period, my period is pi. So I'm going to say 4 squares is equal to pi. Now, whenever we're first graphing these graphs, remember I always like to start with the horizontal change or the vertical shift, but we don't have either one of those things here. So that means that we're going to be starting at 0, and our middle line is going to be the x-axis, just like normal. My amplitude, though, is 1/2, so the top of the graph is going to be here, and then I'm going to go down 1/2. The bottom will be here. The period is equal to pi, which means I need to complete a full cycle by the time I get to pi. So there's my frame. Here's the middle. And we're graphing cosine again, but this time it's positive cosine. Cosine begins at the top. So I'm going to start at the top, middle, bottom, middle, top. And then I'll do one more cycle. And there's a cosine graph, 1/2 cosine 2x. All right, finally number 9. This is the one that involves all 4 transformations. We have an A, a B, a C, and a D. So let's make a list over here of what's going to happen to our graph. We know that the amplitude is 4. The B number is going to affect our period. 2 pi divided by b, which is 2, equals pi. So again, I have a period of pi. My c, we have minus pi over 2. It's grouped with the x. It's a horizontal shift. It's going to be opposite of what we think. Right, pi over 2, not left. And my vertical shift is up 3. So we're ready to graph. Now on the y-axis, the numbers that affect my y's are the amplitude and the vertical shift, 4 and 3. So I can count by ones. I'm just going to mark every other square. On the x-axis, my period is pi, and I'm shifting right pi over 2. So I'm going to start with the period. If I say that 4 squares equals pi, then can I easily find pi over 2? Well, of course, because pi over 2 is just halfway. So pi over 2 would be here. So these units work for us here on the x-axis. So this would be 2 pi. So we've got our axes labeled. We're ready to graph. Always start with the horizontal and vertical shift. I'm going to go right pi over 2 and up 1, 2, 3. That's going to give me my middle line, and also shows where I'm starting to graph. From here, I'm going to look at my amplitude, which is 4. So from the middle, I'm going to count up 1, 2, 3, 4. So that's going to be the top of my graph. And then from the middle, I'm also going to count down 4. 1, 2, 3, 4. So that's going to be the bottom of the graph. Finally, the period is pi. Now remember in the beginning, we said that 4 squares would be equal to pi. So from here, from my starting place, I'm going to count 1, 2, 3, 4 squares. And that means that I need to finish the full cycle of my graph by the time I get to that point right there. I'm going to draw in the middle, and now we're ready to sketch the graph. This time we're asked to graph sine. Sine always starts in the middle, and it's positive sine, so we're going to go up first, up to the top, back to the middle, and then to the bottom, and finally back to the middle again. And I'm going to sketch one more cycle. And there's the graph. All right, let's move on to the next section. These trig graphs and matching with the equations. I'm going to change my zoom. Hopefully you can just follow along on your review if this is too small to see on your screen. This first question here, number 10, on these questions, one thing that I would do is find that middle line. Because the middle line is going to tell you where your vertical shift is. It's also going to help you identify what the amplitude of the graph is. On number 10, the middle of this graph is right here at -1. That's the middle of the graph. So that means that D has to be -1. Now if we look over here at our choices, unfortunately that's not helpful because every choice has a D of -1. But we can also use this to help us identify the amplitude. And if I count squares for the amplitude, it goes up 1, 2, 3. And also from the middle, we're going down 1, 2, 3. So that means that I have an amplitude of 3. So now I've narrowed my choices to E, F, G, and H because those are the ones that have an amplitude of 3. The next thing we should try to figure out is the period. Now remember the normal period for sine and cosine is 2 pi. And if you notice on our graph here, if we start looking here at 0, the end of the graph is at 2 pi. So if I just look at that section of the graph from here to here, from 0 to 2 pi, you can see that we have 2 cycles of sine showing in between those barriers. There's 2 cycles. That means that my B has to be a 2. So now I've narrowed my choices down to E and F. And so between these two, the last thing I'm looking at is the horizontal shift to determine if it's going to be the sine or the cosine. Now we have plus pi over 2 for both of them, and that means left pi over 2. If it's plus, we're going to go in the direction opposite of what we think, which would be left. And so if I go up here to my graph and I move left pi over 2, that's going to be right here. And so if you notice at that point on the graph, it is in the middle and it's going down. So which function starts in the middle? That would be sine. It's going down, and notice the sine function is negative, and so I believe we have a match. This would be answer E. All right, number 11. Again, I'm going to mark that middle line. We know it's at -1 because we figured out they all have a D equal to -1. First thing I'm going to do is look for amplitude. Up 1, 2. So I know on this one that A has to equal 2. So that means I've narrowed it down to choices A, B, C, and D. The next thing I want to look at is the period. Now notice my choices are 3/4 or 1/2. So what I want to do is look between 0 and 2 pi, which would be about right here, and try to determine, is that 3/4 of a graph or is it half of a graph? And to me, it looks like we're seeing half of a cycle because we haven't quite reached the low point down here. Notice the low point is down here at -3, and this graph hasn't quite reached that far down. So we're just seeing half of a cycle here, which means we're going to be choosing between C and D. Now notice on C and D, they both have -pi/2 grouped with the x, which means for both of these we should have a horizontal shift that's right pi/2, opposite direction of what we think. So if I go to my graph and we're counting by pi/4, so I'm going to move right pi/2, which is right here. My graph looks like we're located at the top of the cycle, at the highest point of the cycle. And which of the graphs starts graphing at the top? Well, that's cosine. And so our choice out of C and D for this one would have to be D. All right, let's look at number 12. Again, we're going to draw in that middle line at -1. It looks like, again, we have an amplitude of 2. And so, again, we're looking at A, B, C, and D. We know it's not D because we've already used that one. So let's figure out which B, if it's going to be 1/2 or if it's going to be 3/4. Now, if you compare 12 to 11, hopefully you can see that this cycle is moving a little bit faster on number 12 than it is on 11, which would indicate that our B should be higher. But let's check it out between 0 and 2 pi. Hopefully you can see that that's definitely more than half of a cycle. We've got a 3/4 of a cycle there between 0 and 2 pi, and so that means I'm choosing between A and B for question number 12 because my B is going to be 3/4. So now I'm looking at the horizontal shift, and this time they're different. One of them is right pi/2, the other one is left pi/2. So let's check out A first. From the starting place, if I go right pi/2, which would be right here, then it looks like my graph is in the middle of its range. It's right there on the midline and it goes up. And which function starts on the midline? Well, that would be sine. And since it's going up, it should be positive sine. And that's what we have here. We have a positive sign for answer A. So we have a match. Okay, last question. Again, that midline is there at -1. If I count amplitude here, amplitude is 1, 2, 3. So we have an amplitude of 3, so we're down to E, F, G, and H, although we know it's not E because we already used that one. So F, G, and H. Amplitude equals 3. And so we want to look at the B value. If I look between 0 and 2 pi, how many cycles of a graph do we have? 1, 2, 3. So that means that my B has to be one of these 3s, one of the choices that has a 3 in them. So G or H for this last graph. And if I look at the horizontal shift now, we have plus pi/4 for both of them, which means we've got a shift of left pi/4. And so if I go back to my graph and I go left pi/4, that's going to be right here. Looks like my graph is at the top of the cycle. And which of the functions starts graphing at the top? That would be cosine. And so we've got a match with equation H. All right, so let's move to the next section, and hold on a minute, I'm going to okay, oh, that took me back up to the graphs. Here we go. So in this part, we're being asked to actually write two equations for this graph that we're looking at. One sine equation, one cosine equation. One thing to keep in mind here is that once you figure out the A, B, C, and D for one of them, the A, the B, and the D have to be the same for the other one. Amplitude, period, vertical shift, they're going to be the same whether it's sine or cosine. The only difference should be your horizontal shift or your C value. So let's start making a list of these characteristics here. Again, I want to find that middle line. Draw in the midline first. And it looks like the middle, 1, 2, 3, 4, 5, 6, 7, 8. So the middle would be at 4, 1, 2, 3, 4. Here's my middle line. And I'm going to go ahead and draw it all the way across the graph. So remember the middle line, which is happening at y equal to 2, that is our vertical shift, or our D. So our D value is going to be plus 2. Up 2 is our vertical shift. The next easiest thing to figure out is the amplitude. From the middle, I can count up 1, 2, 3, 4 to the highest point. I can count down 1, 2, 3, 4 to the lowest point. So I know that my amplitude is 4. The next thing we need to figure out is that B value. And in order to find B, I'm going to move over here to the side actually. We need to remember our little formula that period is equal to 2 pi over B. And so if I look at this graph, what I'm going to do is just identify one cycle of the graph, which happens from here. I'm at the lowest point of the cycle, and then here I get back to the lowest point of the cycle. And so if I count how many squares it takes for that one cycle, it takes 1, 2, 3, 4 squares. And this is telling me that each square is pi over 4. So if I have 4 of them, that means that my period is 1 pi. To solve this, I'm going to multiply b to the other side. So 2 pi equals b times pi. And then divide both sides by pi, and they cancel, and b has to equal 2. So my b is 2. Now let me see if I can get rid of that, because we don't need those lines. Okay. All right, so now all we're missing is the C, which is going to be different if we're writing a sine equation or a cosine equation. So let's go ahead and put our A, B, and D into the equations. We're going to have y equals 4 sine of 2 times x plus or minus something we don't know yet plus 2. And y equals 4 cosine of 2x plus or minus something plus 2. So let's start with the sine function. Sine begins graphing in the middle on the middle line. And so I'm going to look along my middle line, and here's a point right here where the graph is crossing the middle line and it's going up like sine should do. That's happening one square to the right, so that's each square is pi over 4, and it's right pi over 4 from where we would normally start. And so in my equation, if I've shifted right, that means I have minus pi over 4. Opposite sign of what we think. Now for our cosine equation, cosine normally begins its cycle at the top of the cycle. And so right here I have a point at the top, and so if I draw that dotted line down, it's crossing the axis at 2 squares. If each square is pi over 4, then that's going to be 2 pi over 4 or pi over 2. It is to the right, and so I'm going to write minus pi over 2. Now those are 2 sample answers. There are many other correct answers that you could give on this question. Let's move on to drawing angles. On these questions, we're asked to sketch a picture of the angle and also determine the reference angle. So on number 15, 315 degrees. if I'm going to draw that angle, it's a positive angle, so I'm starting on the positive x-axis. I'm moving in a counterclockwise direction, 90, 180, 270, 315 is going to be somewhere here in the fourth quadrant. And so that's my angle, 315 degrees. Now the reference angle is always going to be the angle between the terminal side and the x-axis. The angle should always be less than 90 degrees, something between 0 and 90. In this case, my reference angle is this angle right here. And in order to find it, we're going to do 360 minus 315, which gives us 45. And so the reference angle in this example is 45 degrees. Next question, negative 235. So again, we're going to start, always starting at the positive x-axis. It's negative, so I'm going to be moving in a clockwise direction. I'm going to go down 90, 180, but not all the way to 270. So somewhere here in quadrant 2, we have negative 235 degrees. Reference angle, again, is between the terminal side and the x-axis. In this example, that's going to be this angle right here. So in order to find that angle, we know from here to here is 180, and then we've gone to 235. If I do, and my angle is negative 235, so if I add 180, then that's going to give me my reference angle, which is 55 degrees. Or you could have done positive 235 minus 180. Either way, reference angle of 55 degrees. Now this actually would have given me negative 55 degrees, but our reference angles are always going to be positive and acute, between 0 and 90. All right, I'm going to go ahead and clear that and move up for the 2 radian questions. On number 17, we've got 7 pi over 12 radians. It's a positive angle, so I'm going to start here and move in the positive direction. I need to think about this fraction 7 over 12, 7 pi over 12. I know that up here at the top of the y-axis is the angle pi over 2, and over here on the negative x-axis is pi. So what I'm asking myself, is 7/12 greater than or less than 1/2? Well, if I'm in twelfths, 6/12 is 1/2, so 7/12 is going to be bigger than that. So that means that my angle is going to terminate in quadrant 2, just a little bit past the pi over 2 mark. That's our angle, 7 pi over 12. Now the reference angle, again, is between the terminal side and the x-axis. And if this angle is 7 pi over 12, the angle that we graphed, if I go all the way to the x-axis, that's going to be to pi, which would be equal to 12 pi over 12 if I convert it to get a common denominator so that I compare this fraction to pi. So if I've gone 7/12 and I want to know what the angle is between that angle and pi, well, it's going to take me 5 more 12ths to get there. 12 pi over 12, which is really 1 pi, minus 7 pi over 12 is equal to 5 pi over 12. And so that's my reference angle. 5 pi, over 12. All right, negative 11 pi over 4. Now sometimes when we have an improper fraction, when the numerator is bigger than the denominator, it's helpful to think about it as a mixed fraction. 11 pi over 4 would be equal to negative 2 and 3/4 pi. And so I know that 1 full revolution around the circle is 2 pi. So I know I'm going to go at least that far and then a little bit more in the negative direction because this is negative. So I'm starting at the positive x-axis. I'm going to go in the negative direction, 1 pi, 2 pi to here, and now I need to go another 3/4. Well, this is 1/2, 3/4. And so that's what our angle should look like. -2 3/4 pi, or -11 pi over 4. And finally, we need to find the reference angle. Again, the reference angle is between the terminal side and the x-axis. It's this angle right here. And right here, this angle is pi over 4. And so this angle would also have to be pi over 4, because pi over 4 and pi over 4 gives me pi over 2. And the angle in every quadrant, each quadrant is 90 degrees, or pi over 2. So my reference angle is pi over 4. All right, for purposes of this video, I'm going to skip the unit circle. If you still need help on the unit circle, come see me and I'll be happy to help you with that. Let's move on to reference triangles. Number 20. We have the point -512. It's on the terminal side of theta, and we want to find sine theta and cosine theta. So in order to notice in our directions, it says that we do need to draw the reference triangle and then find the requested values. So when I grade your test, I am going to be looking for the drawing of the triangle. What we always need to figure out is what quadrant the triangle is going to be in. If my point is -512, that's going to be in quadrant 2. I'm going to go left 5 and up 12 and plot that point. And so here's my reference triangle. This side is going to be -5. This side is going to be +12. So that's our reference triangle. So now we need to use Pythagorean theorem in order to find out how long the r side, or the hypotenuse side, is going to be. And if you do Pythagorean theorem, you can determine that that side is equal to 13. So now I have all sides of the triangle labeled. I'm ready to find the requested information. Sine theta is going to be equal to, remember that sine is equal to y over r. Our y value is 12, and the r, or hypotenuse, is 13. So sine is 12 over 13. Cosine is equal to x over r. And in this case, our x is -5 because we're in quadrant 2. And the r, again, is 13. All right, question 21. Sine theta is equal to -3/5, and the terminal side of theta is in quadrant 4. So we need to draw a quadrant 4 triangle, which would look like this. Sine is equal to -3/5. Well, we need to remember that sine is equal to y over r. So that means that my y side is going to be -3 and my r is 5. And so we can do Pythagorean theorem to figure out the x side, or just realize this is a 3, 4, 5 triangle, which means my x is 4. And since we're in quadrant 4, that x coordinate is going to be positive. The x value is positive. So I have all 3 sides of the triangle. I'm ready to find the requested information. Tangent theta. So tangent theta is going to be equal to y over x. And in this case, that would be -3 over 4. Let's look at the next two. On number 22, tangent is 15 over 8 and cosine is less than 0. Now remember, we have to figure out what quadrant this triangle should be in. This information right here tells me that tangent is positive and cosine is negative. Well, excuse me. I remember that tangent is equal to slope, and if my slope is positive, that means I have to be in quadrants 1 or 3. That's where I get positive slope, in quadrants 1 or 3. If cosine is less than 0 or negative, that means I must be in quadrant 3, because cosine and sine are both positive in quadrant 1. So I've got a quadrant 3 triangle. Again, because tangent is positive and cosine is negative, that puts me in quadrant 3. Tangent is equal to 15 over 8, and that's going to be y over x. So my y side is 15, My x side is 8. But because I'm in quadrant 3, both of those are going to be negative. Now, when I have them as a fraction, negative over a negative, then it turns positive, which is why there's no negatives up here. But we do need to include them down here. If you do Pythagorean theorem, you can find that the r side is 17. Now we have all three sides of the triangle, and we're ready to determine what sine theta is equal to. So sine is equal to, sine theta is equal to y over r, which is negative 15 over 17. Number 23, cosine is equal to 9 over 41, and sine is negative. This means that cosine is positive, which means I'm going to be in quadrants 1 or 4. If sine is negative, that means it has to be in quadrant 4. So here's my reference triangle in quadrant 4. Cosine is x over r. X side is 9. The r is 41. You can do Pythagorean theorem. You find out that the y side is equal to 40. And since we are in quadrant 4, it's going to be negative. We have all three numbers on our reference triangle, and we're ready to find our requested information. They're asking us to find tangent. So tangent theta is equal to y over x, which in this case is negative 40 over 9.